Alright, so here we are with our last two examples here in section 6.3. In question number 5, we're given a diagram and we're told that triangle TPR is similar to triangle XPZ. Find the length of the altitude PS. So this piece right here, PS, that's what I have to find. Now here's the proportion I'm going to set up for this problem. When we set this up, because we're told that the two triangles are similar, so I'm going to set that up like that. And then it's just a matter of substituting in the values and solving for the unknown. Now the unknown, in this case PS, just go ahead and let that equal x. So set up your proportion and then solve it to figure out the length of the altitude PS. So now when I set that up, you have 12 over 16 equals x over 20. Now I reduce the 12 over 16 just to make the arithmetic a little bit easier. So I reduce that down to 3/4. Still have equals x over 20. Then when I solve for x, you end up with 15. So PS has a length of 15. But here's my what if question. What if instead of setting up TR over XZ, say instead I set up TS over XY? Would I have ended up with the same answer? So I don't know. Let's just kind of check that out. I'll still have that set equal to PS over PY, but then TS over XY, that's going to be the fraction 6 over 8, and I still have x over 20. Now if I reduce the 6 over 8, well, that reduces down to 3/4. Now we can see from there, because that's just going to be the same thing as it was over on the other side, so I'll still end up with PS being 15. So in this particular case, it didn't matter if I used TR over XZ or TS over XY. Most people, when they look at this problem, will probably set up the second one, TS over XY, to solve for PS. So whichever one you do, just make sure that you take your time and you show each one of your steps. Then don't forget to answer the question. PS has a length of 15. Now that's it. We've got one more question to do and then we're done here with this section, and it's been a long section. So here we go with our last example. Example number 6. A town is building a new swimming pool. An Olympic pool is rectangular with length 50 meters and a width of 25 meters. The new pool will be similar in shape but only 40 meters long. We have two things to do. A, find the scale factor of new pool to the Olympic pool, and B, find the perimeter of an Olympic pool and the new pool. So that shouldn't be too bad. Now one of the first things that you always want to do in a problem like this is make sure you draw a model to represent the situation, because we've got plenty of information here. Now they tell us that the Olympic pool is rectangular. Alright, so that means we're going to draw a rectangle for our Olympic pool and a rectangle for the new pool. When you do your drawing, we're going to go ahead and include all the information that we're given. So that's going to look like this. My Olympic pool is going to have the dimensions 50 by 25. Don't forget to add your units in there. My new pool, the only thing I know is that the length is 40 meters. That's what you have to do first, is go ahead and draw a picture. Now, what we're going to do to kind of get after part A, so for part A, we're going to take a look at find the scale factor of the new pool to the Olympic pool. So one of the things I like to do, just to make sure I don't mess it up, is I like to write my fraction new and then Olympic. So that way I make sure when I put my numbers in, that I put them in the correct order. So the new pool, now what I want to do is look at the dimensions here. On the new pool, I have the length of 40 and I also have a length of 50 for my Olympic pool. So those are going to be the two numbers that I'm going to use. So my new pool, I'm going to use 40 meters for that length, and I'm going to use 50 for that. When I reduce that, I end up with a fraction of 4 over 5. So my scale factor of the new pool to the Olympic pool is 4/5. Alright, so that's going to come in handy here in a little bit. Now for part B, when we take a look at that, part B says find the perimeter of an Olympic pool and a new pool. So the perimeter of my Olympic pool is going to be pretty easy for me to figure out, because I know my width is 25, so that means I'm going to have 25 meters on both sides, and I'm going to have length of 50. So to find the perimeter, remember, that's where you're just going to add up all the distances around the outside. So I'm going to have 50 plus another 50 plus a 25 and then plus another 25. So when I add all of that up, I'll end up with a grand total of 150. Now don't forget the units, meters. So 150 meters is going to be the perimeter of my Olympic pool. To find the perimeter of the new pool, we're going to take a look and analyze our Olympic pool, because they're in a certain ratio of the side length, so I want to take a look at that ratio. If you look at the ratio of the length to the width, that is in a 2-to-1 ratio, because here's 50 and the other side is 25. So if I were to reduce that 50 over 25, that gives me a 2-to-1 ratio. Well, check this out. If I know this side here is 40, well, 40 is twice of what number? All right, I'm sure you guys can figure that out. Half of 40 is just 20. So this side is going to be 20 meters, and so is its opposite side. So my two widths are going to be 20 on the new pool, and then my length is going to be 40 meters for that. So again, when you go to find the perimeter of the new pool, you just add everything up around. You just got to take your time, make sure you add up the numbers correctly, and you are golden. So there you have it. The perimeter of the new pool is 120 meters. And again, don't be lazy. Make sure that you write in your unit on there, because you have to have the unit, because that measures distance or length around the outside of our pool. Now, one of the things you can do to check this real quickly, just to make sure that we did everything properly, is we want to take a look at our ratios of the new pool and the Olympic pool, because we came up with a scale factor of 4/5. So what I want to do is kind of take that same idea and see if when I take my ratio of my perimeters, if they reduce down to that 4/5. So my new pool has a perimeter of 120 meters. Now my Olympic pool, that's got a perimeter of 150 meters. So what I want to do is compare that to my scale factor, and they should be exactly the same. So 120, I can take a 0 off of both of these, because really what I'm doing is dividing by 10. So then I have just 12 over 15. And then 12 over 15, I can divide 3 into each of those. 3 goes into 12 4 times, and 3 goes into 15 5 times. So that does reduce down to 4/5, which is the exact same thing as my scale factor. So that tells me that I know that I did this problem right. Pretty easy. I'm sure you guys have this, no problem, and you'll be rocking this stuff out pretty soon. All right, thanks for watching all this. I know this was a lot in this section, but that's all right. You guys can handle this, and you got this stuff now. Have a great day. Peace out, and I'll catch up with you later.